So in order to get a handle on subtracting two vectors, we first need to take a step back and say, what is subtraction of numbers themselves? What is 5 minus 6 really saying? Well, this is really saying add 5 and then the number negative 6. And the number negative 6 is it's called the additive inverse. Additive inverse to 6, this number. So when you add two numbers, or when you subtract two numbers, you're really saying add them, but add the first number and then the additive inverse of the other number. What do I mean by additive inverse? Well, additive inverse is the number, so this guy is the number such that 6 and negative 6 add to 0. It's the number that is the opposite of 6, additive inverse to 6. So if we want to do subtraction of vectors, we need to get a sense of an additive inverse. And in order to get an additive inverse, we need to define something called the zero vector. All right? So let's get at what the zero vector is first. So zero vector is just a vector with length 0. So that means we go nowhere from the origin. We go 0 in the x and 0 in the y. A vector with 0 length or magnitude. And so what happens when you add a vector and the zero vector together? Well, you're going to get, so say your vector is AB, A plus 0 and B plus 0, which doesn't do anything to these numbers. A plus 0 is still A, and B plus 0 is still B. And so you get the vector you started with when you add the zero vector to it. And that makes sense. That's the same as adding a 0 to a number. It doesn't do anything to it. So adding a zero vector to a vector shouldn't do anything to it. So what is the additive inverse of V? The additive inverse of V, and it's denoted with a minus sign, just like in regular math, negative V, is the vector such that V and negative V add to 0. So that's the key behind the reason why we create this zero vector is so that we can create additive inverses so that we can then talk about subtraction of vectors. If we don't do all this machinery behind the scenes, then we don't end up having a really strong understanding of what is subtraction doing, what is subtraction of vectors. If you add a vector and its additive inverse, you get 0 out. So what is the additive inverse of V? If V is equal to the vector AB, well, you want AB plus whatever this vector is to equal 0, 0. So the only way for this to happen is if, because these first components add and the second components add, how do I get 0? By adding a and a number. The only way for this to work is if this is negative a. And the only way for me to get 0 by adding to b is if this one is negative b. So the additive inverse vector is just the negative of both of the components of it, of the original vector. So that says that if v equals AB, then negative V equals negative A, negative B. It's just the negatives. And you might ask the question, what's the direction of this additive inverse vector? The direction of the additive inverse vector is in the opposite direction of the vector v. As the same slope, you can check by dividing b over negative a and b over a. It's the same slope, but it's pointed in the other direction. This one can be going up and right, the other one would be going down and left. Okay, so then we define subtraction. Let's say this. If u equals some other vector CD, then define, let's say, v minus u as v plus negative u. We say that subtraction is really addition, but you add the negative, the additive inverse of u. We add the negative of u to v. And so what does this mean with the components? That says that we have a, b, and then we're adding to it negative c, negative d. So what is that really equal to? A and negative c, which is a minus c, and b and negative d, which is really b minus d. So when you subtract two vectors, you just subtract their components. Let's see if all that's in there. Yep. Okay. So what does this look like graphically? There's our subtraction of vectors right there. B minus u, you just take the components and you subtract them. Graphically, let's get a handle on this with an example. We've done a lot of work with just letters. Now let's put some numbers in and see what subtraction does. So let a equal, let's do the vector 4, 2, and b be the vector equal to 2, 3, for instance. And I'm going to draw a minus b. Or let's say this, show the vector difference a minus b. Okay, well let's calculate it first, algebraically. A minus b equals a plus negative b. Or you just take the components and you subtract them. Well, let's keep it simple. This is just equal to 4, 2, oops. Yeah, 4, 2 minus 2, 3. And this is 4 minus 2 and 2 minus 3, which ends up being 2 and negative 1. Okay, so now that we have an answer for the subtraction, it's 2, negative 1, let's sketch what this looks like. I'm going to move this over a little bit. So let's get 1, 2, 3, 4. 3, 4. That's pretty good. So I'll draw vector A in blue, or red. I'll draw this one in, what did I do it last time? I don't recall. I did that one in blue. I think I did this one in green, actually. This one in green. And I'll draw the difference, A minus B in blue. Okay, so first sketching A, 4, 2. This is my point 4, 2, and that's vector A. Now let's look at green. That's 2, 3, 1, 2, and 3. That's B. And let's sketch the subtraction to -1. I actually need to go down 1 unit. So 2 in the x and -1 in the y, that's my difference vector. This is A minus B. A take away B. So where does this vector show up in this picture? Well, if you look at this, it's actually the same vector as going from this tail, the tail of B, to the tail of A. And so another way to think about vector subtraction is it's, if you draw the vector of B, the vector you're subtracting from, and the other vector A, then the difference vector goes from the tail of B to the tail of A. It's this vector, which is the difference between the two. Because this is the same, this has a coordinate 2, 3, so to get here, that's right 2 and down 1, right 2 and down 1. Same exact picture. And basically what we're doing is we're going A, and then we go negative B. This is negative B. And this is where we wind up. We go A, and then negative B, which is the same length of B, but in the opposite direction. And it sends us to this point right here. So that's graphically what's going on. The easiest way to see that, though, to find this vector, is to just draw the arrow, the vector connecting the endpoints. Now, you wouldn't want to draw the vector going from this endpoint to this endpoint. That would end up being B minus A. So in order to subtract two vectors graphically, I'll just write the steps down. To subtract two vectors graphically, or geometrically, draw each vector with initial point 0, 0, and then draw the vector we could say this, to subtract A minus B, because vector, the order matters. To subtract A minus B, do A take away B, draw the vector from the endpoints of B to the endpoint of A, and that vector is the difference vector. That vector is A minus B. So that's how you would do it geometrically by drawing the vectors on a coordinate plane.